Welcome to the Audio Guide to the Galaxy, a podcast put together by those of us at Scitech to help you keep connected with our wonderful night sky. We are back for a second season, continuing our journey of exploring the night sky and discovering what there is to find in our universe. If you haven't listened to any of these before, that is okay. The first episode is a nice introduction to the night sky for complete beginners. And for those of you who have been listening, never fear, there is still plenty of new stuff for you too. Plus, it's always good to get a bit of a refresher. My name is Leah, one of the presenters in the Scitech Planetarium, and tonight we are going to map your world, learning all the tricks on how to navigate our sky and then putting our skills into practice to finding the great centaur in the sky, Centaurus. This recording, it's time to take place at 7 p.m. on any night of the week starting from Friday the 29th of May. So take this out whenever the time and weather suits you best. As always though, I want to make sure you are feeling comfortable as you are gazing up at the sky. So make sure that you are wearing nice warm clothes before heading outside. Are we ready? I'm going to assume you said yes, so let's begin. One of my favourite quotes is that the night sky is a window to our universe. And it is so very true, because the universe isn't hidden from plain sight, reserved for just those special few who know how to find it. It's right there. Look up right now. Take in every bright flickering bit of light, every dark patch, every single detail. All of that is part of the universe and holds many secrets waiting to be discovered. And those secrets are easy enough to find if you know where to look. But before you can find anything, you need to be familiar with the night sky and know how to navigate it. Looking up at the moment, you can see many stars shining bright, perhaps even spot some familiar objects. But it's all a little chaotic. To help you find those special objects, we need to make sense of that chaos and define it in a way that makes sense to us. The easiest way to begin is by knowing your directions: north, south, east, and west, what we call the Cardinal Directions. So, how can you figure out which way is which? The simplest way is to find out by using a compass. The point shows you the direction of north, and from there you can figure out the rest. But what if you didn't have a compass? Well, that's when you can use the sky to help you figure it out. The way to do this is by being familiar with some key objects in the sky. The first is the sun, one of the few constants in the sky. Do you know what direction it rises in the morning, or what direction it sets in the evening? We know it rises in the east and sets in the west. A simple enough question, but a meaningful answer, because once we know the answer, then we can figure out what way each direction is depending on the time of the day. For example, if it's in the evening, we would know that wherever the sun is, that way is west. Of course, right now, the sun has long since set, and instead we have a sea of stars to help us find our way. While it may be difficult to make sense of the countless stars we can spot in the sky, remember that people from across the world, from all different cultures, for thousands of years, have been making patterns out of those stars. Those patterns, or to give them their proper name, constellations, are not only captivating, but also very useful in helping us to navigate the sky. And amidst the many stars and constellations overhead right now, there is one constellation in particular that can always help us find our way. And it is none other than the Southern Cross. The Southern Cross is a famous constellation, easily seen in the Southern Hemisphere. It is also perfectly placed in our skies that we can see it nearly all year round, making it another constant of the sky. This is the reason it is useful in helping us find the cardinal directions. So let's do this together. Have a look up and see if you can spot the Southern Cross. Remember, it is 4 stars that make a well-defined cross, with an extra faint 5th star towards the lower right of the cross, much like we see on the Australian flag. Alright, do you think you've found it? There is an easy way to test if you have the right cross, and that's because whenever you are trying to find the Southern Cross, there are 2 bright stars that point us in the right direction, known as the pointer stars. Tonight, you will find these 2 bright stars just to the left of the Southern Cross. Can you spot them? Now, the easiest way to use the pointers is to start with the leftmost star, bright yellow in colour. Then draw with your finger a line across to the other pointer star, bright blue in colour. Now, keep drawing that line with your finger, and it shouldn't take you long to reach your cross, the Southern Cross. The pointers and the Southern Cross are located in the southern skies, so once you've spotted them, you know you're facing towards the south. But, much like a compass pointing directly north, these 2 star patterns can point you directly south. You may remember how to do that from season 1, but in case you don't or this is your first time, I'll guide you through it. The first thing to do is to get your drawing finger out again, and starting with the topmost star of the cross, a bright red star, draw a line down through the long axis to the bottommost star of the cross. Now keep drawing that line out into the sky, following along the same direction. Alright, now focus your attention back to the pointer stars. Find the middle point between these 2 stars and place your drawing finger on that spot. Draw another line from this point out into the sky, and the direction of this line should be sticking out exactly sideways from the line we drew earlier to find the Southern Cross. Now we need to draw these 2 lines again, but this time at the same time. So you'll need 2 drawing fingers. As you draw these 2 lines, you will notice a spot where they meet, or your 2 fingers touch. This spot is the South Celestial Pole, quite literally the South Pole in the sky. All that's left to do is draw a line from the South Celestial Pole straight down to the horizon, giving you directly south. From here, you can find the other directions. Turn behind you to face the exact opposite direction. This is directly north. Now, if you turn to your right, this is east. Turn to your right again. We know this as south. And finally, turn to your right one more time. This is west. So following that silly phrase, never eat soggy Weet-Bix, we can find the directions in the order of north, east, south, and west. Now that you know your precise directions, it makes finding objects in the sky just that little bit easier. But we can make navigating the sky even easier by using our hands. Sometimes you might hear phrases like, to find the pointer stars, you'll spot 2 bright stars in the southern sky that are roughly 2 finger widths apart. The reason why using your hands is a useful tool is because it's actually measuring out the distance between objects in the sky, what is known as angular distance. As you start from the north and spin around to face each direction, you are tracing out a circle, spinning around 360 degrees to get back to where you started. If you turned from the north to face east, you are turning 90 degrees or covering 90 degrees of the sky. It's a little bit like when you are cutting up pieces of a pizza. If you cut it into 4 equal pieces, the angular distance of one piece from one side to the other is 90 degrees. We do the same thing with the sky. We can separate it out into pieces to help us measure the distances between objects in the sky. And our hands and fingers are useful tools to help us do that. So, for example, if you face north again, I want you to place your hand out in front of you at full arm's length. Now stretch your fingers out as wide as possible and notice how much of the sky it covers. The distance between your thumb and your pinky is approximately 22 degrees of the sky. In total, it would take 16 handspans to cover the entire sky, starting from north, spinning all the way around back to north again. But we can measure out smaller distances too. For example, if you now hold out your pinky finger at full arm's reach, your pinky covers 1 degree of the sky. So it would take 360 of your pinkies to reach all the way around the sky. Being able to measure out distances in the sky makes it much easier to find objects, especially when you can use your hands to do it. But remember that the sky isn't a circle, but a sphere, not only stretching around us, but up over us too. Astronomers describe the sky as a celestial sphere, and when we are navigating the sky, we need to use a coordinate system. This is a reference that can tell us not only what direction we need to face, but how high up in the sky we need to look. It makes finding objects much, much easier. The key words to listen out for are azimuth and altitude. Now we've already covered azimuth. This is our cardinal directions north, south, east, west. Altitude, on the other hand, tells us how high up the object is by using the horizon as a reference point. It is also measured in degrees, which means we can use our hands to measure it out. The simple thing to remember is that horizon is 0 degrees and directly above us is 90 degrees. So, for an example, to find an object halfway up in the sky, it would be 45 degrees, or roughly 2 handspans above the horizon. Easy. Now, for all our talk of constants in the sky, there is one key thing you need to remember when navigating. The Earth is not constant, it is moving. Sometimes it's easy to forget that fact when we can't physically feel it moving underneath us, but we can be reminded of it in our sky. The easiest thing to note is that our Earth rotates on its axis. We see this as our sky changing from day, when the Earth is facing towards the sun, to night, when our planet is facing away from the sun. We can physically see the rotation as the sun moves across our sky from east to west, and likewise the stars at night follow the same path. But our sky can also change day by day, in a way that is sometimes harder to notice. Because remember, the Earth doesn't just rotate on its axis, it also orbits the sun. And this has an effect on our sky too. But it's something you can only really notice when you are looking at the night sky. You see, a month ago, we were pointing out constellations like Orion and Canis Major. But as you look up now, it's changed a little. There are still some familiar objects to spot, but we are now getting treated to a whole new branch of constellations in the eastern sky. As our planet makes its yearly journey around the sun, the stars we see in the sky change over the course of the year because the Earth is physically moving to a different spot in space, giving us a slightly different part of space to look at. So in summer, we get to see summer constellations like Orion, but as we make our way to winter, 6 months later, the Earth has moved to the other side of the sun in its orbit. This means we can no longer see Orion during the night, now hiding behind the sun. Instead, we get to spot winter constellations in our night sky. A year later though, as the Earth continues back around the sun towards the starting point in its orbit, we once again get to see Orion. But see if you can notice the Earth moving in its orbit by testing out an experiment. Have a look back at the Southern Cross. Take a note of the exact time on your watch right now, and then try to use reference points to mark exactly where the Southern Cross is in the sky right now. You might use things in your backyard like a fence, some plants, the roof of your home, anything on your horizon that helps you define where it is in the sky. Now tomorrow night, at this exact time, I want you to come back out and have a look at the Southern Cross. See if it's changed in its position at all in relation to your reference points. It might be difficult to spot after one night, but keep doing this for a whole week, night after night, coming out at this time and see where the Southern Cross is. You should start to see that it has moved just that little bit in the sky. You can also try and use your hand to measure out how far it has moved in the sky over the course of 1 week. And when you do that, you will be measuring the movement of the Earth's orbit with just your hand. How cool is that? It does remind us, though, that the Earth is constantly moving beneath our feet, but it is also connected with the rest of space in a way that we can see. Now that we are all navigational experts, let's put it into practice. I want you to find the point in the sky that is south and 50 degrees above the horizon. What can you see? Hopefully, you're looking at the pointer stars, 2 very bright stars in the sky that are roughly 2 finger widths apart, or have an angular distance of 6 degrees. These 2 stars are special because they help us to find the Southern Cross, but they belong to their own constellation of Centaurus. Constellations are another useful method in helping us to navigate the sky. While making patterns and pictures out of the stars in the sky is a fun way to spend the time, constellations themselves do serve a useful purpose. They are a map to the night sky. Much like we have maps here on Earth to help us to get from one destination to another, using reference points like roads or buildings, constellations are the reference points in the night sky. In total, there are 88 constellations recognised by the International Astronomical Union. These 88 constellations cover the entire night sky, both in the north and southern hemisphere, and they guide hopeful stargazers to their celestial destination. Centaurus is one such constellation, and in fact a rather large one in the sky, surrounding the top half of the Southern Cross. The constellation represents a centaur, the mythological creature that is half horse and half human. Basically, it looks like a human head and torso attached to a horse's body. You may have come across them before in myths or books or movies. For example, they were one of the creatures hidden in the Forbidden Forest in Harry Potter. This particular centaur, though, originates in Greek myth and is often depicted as Chiron. Chiron might not sound like a familiar name, but he was the wise tutor of many Greek heroes, such as Heracles, Jason, Achilles, and Theseus, names you may have heard before. He passed on great knowledge to many heroes, but ultimately suffered a miserable death. He was accidentally struck by one of Heracles' arrows that were dipped in a poison that had no cure. While Chiron was immortal, it meant that he could not die, but endured terrible pains. That is, until the god of Greek gods, Zeus, took pity on him and released Chiron from his immortal life, allowing him to pass away in peace. Zeus rewarded Chiron, though, by passing on his immortality to the sky, placing his likeness up there for all to see. Or at least, that is how the myth goes. For the constellation of Centaurus, the most notable stars are the 2 pointer stars, Alpha and Beta Centauri. Alpha Centauri is the bright yellow star that is a little closer to the horizon, and Beta Centauri is the blue whitish star above it. Together, they mark the front legs of the centaur. These two stars are also the brightest stars in the constellation. The rest of the stars are not as easily recognized, but together we can trace out the shape of the centaur. You can find the back legs of the centaur on the other side of the Southern Cross. Draw out a line in the sky that starts from Beta Centauri, the bright blue pointer, through to the bottommost star of the Southern Cross. Now stretch out your hand along the direction of that line with your thumb placed over Beta Centauri. Just next to your pinky, you should see a small, faint white star, much fainter than the stars around it. This star is Lambda Centauri, a star that is 420 light years away from our solar system, one of the reasons it appears so faint in the sky. While the star itself may not be as captivating as the bright pointers, Lambda Centauri marks the back legs of the centaur. This gives us an idea of how far Centaurus stretches across the sky. But let's see how high it stretches up by finding the centaur's head. Its head can be represented by a star that goes by the name of Menkent. To find Menkent, start at the middle point between the two pointers like we did before. This time though, rather than drawing towards the south celestial pole, I want you to draw in the exact opposite direction, upwards. Keep that line going in this direction for about 1.5 handspans, or an angular distance of 40 degrees. Now, if you look just above this point, you should see a bright red star. This is Menkent. Many drawings of Centaurus show Menkent as the head of Centaurus, but interestingly enough, the name Menkent is actually derived from the Arabic word for shoulder. But as we always say, the pictures of constellations are open to interpretation, so I'll leave you to decide whether you think it's the centaur's head or its shoulder. Now, with the head and the legs of the centaur in place, mark these as our reference points. Using your imagination, see if you can map out the rest of the shape of the great centaur Chiron in the sky. With all that done, you have just successfully mapped out part of the night sky. That does bring us though to the end of episode 1 for our second season of Audio Guide to the Galaxy. Tonight we learnt the basics of stargazing navigation and using it to spot the constellation of Centaurus. Having these skills means we are now ready to explore the night sky in a little more detail and discover what secrets are hidden out there in the cosmos. But here is one more secret for you. Gazing up at the night sky, our window to the universe, remember that we exist in it, that you are part of this great universe. So to finish off, borrowing words from the wonderful Carl Sagan, we truly are a way for the universe to know itself. So always remember, you can find it just outside. Good night, everyone.